I want to welcome everybody to this Zenith installation seminar. Especially appreciative to Don for bringing that fuselage here for us to operate on over the next couple of days. And hopefully he'll leave here with a engine on and cowls fitted, oil cooler system done, carb heat system done, and pretty much everything except the propeller, I suppose. Pretty much everything firewall forward done over the course of a weekend. Mark Stauffer is going to be your primary instructor, and I'm going to be here for backup and to take a few pictures. John Croak was kind enough to come down and video this, so hopefully through his HomebuiltHELP website that future Zenith builders will have a good understanding and a good reference for installing engines on Zodiacs from now on. What I'm going to do first is just for those of you who haven't been through one of our seminars before, a little background on where this Jabiru engine came from. In the late 1980s, Jabiru, Rod Stiff and Phil Ainsworth, the primary owners, developed a light airplane for use in the training part of the Australian ultralight class. The Aussie ultralight class is a bit like our new light sport class in that didn't need a medical, reduced training requirements, and they were in some sense in the same position that light sport is in the US, in that there was a lot of interest from pilots but no airplanes to train pilots in that would fit into this Aussie ultralight class. So Rod and Phil developed this airplane, and they were powering it by an Italian KFM engine, 60 horsepower, flew fairly well. Not long after they first certified that airplane, KFM notified them that they were discontinuing aircraft engine production. So here these two guys had invested everything they had virtually into this project, and now they had a plane without an engine. So they investigated other alternatives. They fitted a Rotax 582 on one and flew it for about 20 hours, had 3 engine outs in that 20 hours, and decided that that was not an acceptable alternative. They looked at the 912 but thought it was too heavy. Looked at Volkswagen derivatives and anything else that was out there and weren't happy with what they saw. Rod Stiff, who was the engineer side of this partnership, decided that he could build his own engine that would fit the needs for his airplane. So that's where the engine actually came from, where it started. The first engine they produced was 1600 cc's and 60 horsepower. I think they produced about 90 of those. About 60 Jabiru airplanes were powered by that engine, and 30 were sold to other builders doing home built projects. In 1994, they brought that engine and the airplane to Oshkosh to show it off to the world, and there was a significant interest, but it was clear that the US market anyway thought that 60 horsepower was not enough. So they redesigned from a 1600 cc to a 2200 cc, and that's the basis for the engine that we see today. In 1997, they took that same engine essentially from 4 cylinders to 6 cylinders. We saw the first 6-cylinder engine in the US in where was that? At Oshkosh of 1998 on a Titan Tornado, and that engine is pretty much was in the same configuration of the engines you see today. A couple of major changes along the way. In 2000, they redid the intake manifold and carburation on it, resulting in some more horsepower. The other really major change came for the 4-cylinder in June of 2005, and that was hydraulic lifters instead of mechanical lifters. And that same change got to the 6-cylinder in April of 2006. To this point, Jabiru has produced about 5,000 engines. JabiruUSA has sold a little over 1,000 of those 5,000 engines. In addition to selling the engine, we recognized early on in 2001, when we were getting more calls from frustrated builders than anything else, that knowledge of how to install these Jabiru engines would be very important, and also a correctly designed cowl and firewall forward system were going to be very important. To that end, well, in 2003, there were two, just referencing the Zenith for instance, there were two firewall forward kits being produced for the Zenith. One was produced by Zenith Aircraft Company, which was a modification of their cowl that they were using on the 912 Rotax series. Fitted it over the Jabiru, and it looked pretty good, but it did not cool very well, especially on the oil temperature side. It didn't do well at all. Cylinder head temperature was marginal. Another kit was being produced by Jabiru Australia, and that cowl typically cooled very well, but it was pretty ugly. It really didn't do anything to help the looks of the 601 at all. In early 2003, we had the opportunity to work with Al Beyer in Oshkosh, Wisconsin, and he brought his Zodiac HDS up to our place, to our fiberglass guy, and we started with a Jabiru produced nose bowl and built a cowl to fit the Zenith from that nose bowl on Al's airplane, and then brought it back to our place and fitted up oil cooler systems, carburetor heat systems. The Airbox that was being used that came from Zenith was inadequate, and the one that Jabiru produced was too big to fit on the firewall of the Zenith. So little by little we put all these parts together, and now we manufacture firewall forward kits for Zenith 601, and now Zenith 701, Rand's S7S, and also a Kit Fox 7. So we've gone into the the component manufacturing business, as well as just importing engines and kits from Jabiru. Zenith builders are our biggest customer group. They account for an average, probably, I don't know, 10 engines a month, firewall forward kits and so forth. You can see the photo on the front of this set of instructions. That's Al Beyer's airplane in front of Al Beyer's garage on the shore of Lake Winnebago, just on the north side of Oshkosh. And you'll notice that this cowl is not the same look as what we have today, but the Jabiru J400 4-place and J250 and 450 2-place airplanes from 2003 through 2005 about. If you look at the front end of those and look at the front end of Zenith, you'll see a lot of similarity there. Jabiru changed their system in mid-2005. So it was, well, about the end of 2005, we changed the Zenith cowl as well. So now for the last almost 2 years, we've been marketing a cowl that, again, looks like the front end of a Jabiru, and it does cool a little bit better. And I think all around has just a little bit better look. And that's what we're going to be working with today and tomorrow and Sunday morning. So I think that I hope covers most of the history of where we're coming from here. This seminar is going to be very informal, and it's also going to be very hands-on, in that we're going to take pieces out of these boxes and hand them to you guys and tell you it belongs on that firewall and give you some instructions on where to put it. But you guys are going to do most of the work. I think that's our plan. And so at any time, if there's something that's not clear, there's a question or something we skipped over or explained in a way that is incomprehensible, stop us. Let's back up a little. We'll start over again. We'll explain what we're doing and why we're doing it. And if there's alternative ways to do things, we'll try and cover them too. So with that, let me turn it over to Mark.
Well,
and
uncrate the engine here.
Okay.
So, yep, we're going to work on that one. So this is the engine. Do what?
He loses his table.
He loses his table. Yep. Well, this is the crate as it comes to you. So first thing we do is get a screw gun or something, and don't waste the time of taking the screws off the top. There's 4 screws around the sides here. There we go. So that is Don. There's your engine. We can talk about the parts in a minute, I suppose.
Mm-hmm.
Does it come this way from Australia?
Mm-hmm.
Yep.
This
came off the container on a Monday, a little over a week, November 5th or something like that. It was a Monday morning, a week and a half ago.
That's a zero-time engine.
what is this coming like? There we go. Goodness. Go ahead and lift it up. We're going to lift it up. It's not going to roll out. We'll have to take the screws out of the back of it. There we go. Okay, now somebody get in the front here and just keep it from going forward on you. And there's 4 screws on the back side that we're going to take out. Okay, you got it?
Yep.
Now, it should walk towards you a little bit. There we go. Okay, Carl, if you take the box back, you can just let it roll, let it come over forward and sit on the oil pan. Yeah. There we go. Okay. Good. Next thing to do is we'll go ahead and take this cradle off. That's a 7/16.
Yeah, I mean, if you're going to have these for a long time, it's best to keep them at an even temperature. You know, that proverbial cool, dry place. You know?
Mm-hmm.
And what I like to tell guys to do is get some of these silica packets that absorb moisture, and just throw them in the box. Leave it in the shrink wrap. Just throw those silica packets in the box. And we've had guys that have had them like that for 3 and 4 years with no ill effects.
Or move them.
All right, next step, just get all the plastic off of it. So just start cutting the plastic off.
Do you?
A little bit of what we call packing oil or shipping oil that is in there. They call it, it's a very heavyweight oil. They call it honey down there. But that's, yeah, when we get to the oil cooler here, you'll see a little bit in there. Oh, do they have it?
Let me just show you this. This probably, most likely, will be in your engine. This is the packing list of what Jabiru has put in this box in Australia. And Dana took this one out, and she looks them over before we send the engines out. But it'll tell you it has an exhaust system, and this one actually is for a 2200 pusher. So they have a line drawn through the tractor exhaust system. You can see they have pusher muffler, and pusher ram air ducts, and all these things are in that box, and that's what you do your inventory on when you take it out of the box.
Okay, the other things that were in the box, here are the ram air ducts for cooling. They'll fit on top of the cylinder heads here, and we'll go into these a little bit later on. But those are in there. Here's the muffler. It's a single pipe muffler with the collectors on the back side there.
Is that all stainless?
Yes.
Yes,
These
that
are
is
stainless.
304 stainless, I believe it is.
And this is the prop flange, the extension hub.
That's the 2-inch extension?
Yes.
Yeah.
Sometimes that's referred to as the 63 millimeter extension, which is 2.5 inches, but that's the distance, the whole height of that, 2.5 inches, but it extends the prop out 2 inches. And sometimes Jabiru themselves refer to that as a 2-inch extension. Sometimes they'll say 63 millimeter extension.
And the other thing that's included inside the wrapping there is the goodie bag here.
Yeah, that is called the engine installation kit.
Okay.
That's what's on your parts list here as the engine installation kit.
All right, we'll just go through the bag and kind of identify parts here. Thanks. All right, this is the regular rectifier. And that's just how it comes to you. We'll get into that a little bit later on. Probably tomorrow we'll talk about where the colors go and how to hook that up. These little guys right here are your motor mounts. These are, we call them butterfly plates or whatever, but they actually fit in here, and they're deflectors to help the cooling air go around the heads and not the cylinder barrels. We'll put those on. Oil cooler bypass, or the
That's called an oil cooler adapter, is Jabiru's official terminology for that.
So, and that's where we're going to use this. We're going to put it underneath the oil filter here. Let's see what else.
Do that part next.
Ah, yes.
That's called a threaded adapter.
Threaded
is the official
adapter.
name.
Again, when you bring this part out, this will screw onto the stud that's in there, and then this slides over, and the oil cooler goes back on. So you got those two together.
We're going to change out these two.
Yes, you're going to change those out. We'll get to that when we do the oil cooler installation. That's a new box. Star solenoid. The only connections you have is battery, starter, and then your solenoid off your key. You know what I mean? Your key start, the switch off the key. Crush plate, prop crush plate. So, and this is drilled for a wood prop. Well,
Yeah.
of course it's drilled for wood.
Now, when you get these crush plates for the prop, you'll see that they're drilled for 1/4 inch. And those are the bolts that Jabiru uses on a Jabiru propeller on Jabiru airplanes. However, most prop manufacturers in the U.S., Sensenich specifically, that we use extensively, they don't think 1/4 inch is adequate. So the props that you'll get with these firewall forwards kits have 3/8 bolts. So one of your jobs will be to drill these 1/4 inch holes out to 3/8.
Yeah. Fancy technique for that?
3/8 drill in a drill motor, like Mark was taking the screws out with. That's all there is to it.
Yep.
So you don't need to use those.
Actually, while we're talking about this propeller, let's just look at, there's 6 of these propeller bushings that come with this engine, and they go in the prop hub just like that. And you see these are also drilled at 1/4 inch, and you know, they look like they're stainless and really hard, but they drill really easy. So you put these in a vise with a cushion on each side of a stick of wood on each side or something. Just take a 3/8 drill and right down through there. And we'll have you doing that a little later in the class.
The mounts, you know, fit together like this, obviously a male and a female. And then this little guy, it goes on the front side. So what you're going to see is something like this right there. And also, if you need to shim your engine out for any any reason, these are little shim washers that you can put on the motor mount, and we'll get to that in a little bit. But basically, it'll fit something like so. That's if you need to shim up or down, shim your motor up or down.
Which one goes on top?
And these are the springs for your muffler to hook on the muffler onto the tailpipes here. There's a welded tangs already on there for them. There's safety wire included. So when you're putting on the plates here, safety wire is already there. They throw it in the bag. And
they even provide you with 1/8" rivets. I'm sure you Zenith guys are always short of those. Guys who get their engine, they take the top off and they look in there and they take the inventory sheet out and they can't find the engine installation kit, because sometimes that is tucked down underneath here inside that shrink wrap, but it's always there. It's just that they don't see it. So if you're not going to use your engine right away and you want to see where that is, just put a mirror down in there and look around. You'll see it tucked underneath the shrink wrap.
all right, so we've gotten the engine out of the box. We inventoried everything through there. I guess the next thing we can do is clean this up just a touch, and we'll open up the firewall forward box and we'll start pulling the parts out of there. Here we go. Okay.
Yeah, let me see that just a minute. I get a call probably at least once a month again also as to my solenoid doesn't work. And which terminal do you put the wire to? Well, when this is held up here so that these big lugs are pointing upward, you see there's 2 terminals on the side, and one is a little farther down below the other. It's the lower one that your wire from your key switch or your ignition button, starter button, goes to. And you can also tell that if you just ground the base and put 12 volts to either this side or that side. If you put it to this side, nothing happens. If you put it to that side, it goes click. You know that's the side that you wire your wire from the starter button to.
All right, this is where it gets messy, depending on how she packed it.
Now all these firewall forward components are put together by Bonnie, who usually works up in that room there, and you'll see her come down here to do things. Bonnie is the parts manager and firewall forward person who, when we get a shipment in of engine mounts, you know, she'll put them over there. When we get a shipment of cowls in, she'll put them over there, and then she packs these boxes. She also builds the air filter boxes, builds carburetor heat kits. She builds the muffs themselves. What else does she make? She puts all these various subcomponent kits together.
Runs your whole parts inventory up there.
Okay, this is what it's going to look like in here. Built that up a little bit. That's what it'll look like when it comes to you. There's a bunch of bubble wrap in there and some accessories. We'll just start unpacking.
All right. And they'll have like this one right here. Let's see, the cabin heat kit. So that's this one. And you've got which one?
Dual throttle kit.
Yeah, you're doing dual throttle.
Here, I'll take that.
Yeah, these are just to take up space.
Yep. You'll find various used boxes in these kits, again, just to take up space to help keep things from rattling against each other too much. Yeah, there should be one of these boxes labeled cardboard.
Well, our cardboard box moved over there, Pete.
Where?
It's the flat
it's
cardboard
over there?
box is over there now. Yep.
Okay. Looks like it's over
There
by
we
the
go.
door over there.
Yeah, go ahead and grab that box out. It's got all kinds of pieces and parts in it. And just flip it on its side. Carl, here you go.
Now, the engine mount is going to be zip tied to the bottom of the box so that it doesn't move around. You have to cut those zip ties to get the mount out.
Should be two, one.
Okay. You got it.
There we go.
Got it. Embedded in the box.
Ed just asked what the point is in painting them. The mount is made out of 4130 steel, which you know from working with your Zenith kit, if you leave it out in the moisture, it will rust and quickly. So it's just corrosion protection, rust protection is the only reason it's painted.
I'm just unwrapping the airbox here. There we go. Yeah,
Probably, I guess. Yeah.
scat hose. And again, these are coming out labeled. So this is your carb heat components. So it comes with the clamps, the push-pull cable in there, whatever else parts we need to put the carb heat on. Here's the oil recovery system. Again, with all the clamps, everything we need. Our battery box assembly. Choke components, cable and the ferrules. Part of the oil cooler kit here.
The fun part.
Yeah. Yes, this is all your cowls, your cam locks, everything you need to put your cowls on, fasten your cowls to the airframe. Oh, we're going to need this. Nope, sorry, this is the motor mount. This is the engine side. Fuel pass-through, fire sleeve. There we go. Firewall side mount hardware. We're starting to include the AN6 bolts because Zenith changed the way they're doing the bolts now. Don's kit is like my old kit. The bolts are already welded onto the upper and lower longerons. Well, they quit doing that now, so we won't need the bolts out of here, but we'll definitely use the nuts and the washers on there.
Mine's half and half.
Half and half.
Well,
You're in.
I ordered the new top engine mounts. So my top engine mounts are the new ones and the bottom engine mounts are the old ones.
Oh my goodness.
But it works. It just makes the canopy easier to mount.
The muff for the carb heat.
I was talking to Roger and he said, "Oh, those are new now."
To my engine mount bracket.
Where's mine?
And this is the oil cooler. So
I didn't have these.
you didn't have those in your kit?
Oh, I don't think so.
Well,
Okay.
there was a time Zenith made this change and never told us. So we were supplying nuts, which is all we would need for a kit like that. So you may have 4 nuts and washers and no bolts, but if you need bolts, you know, Bonnie or Dana can get you bolts. And
I think the bolts, although they're not welded to the bracket,
Bolts came with mine.
yeah.
Yeah, they don't. They're not welded,
Yeah.
but they came with it.
okay.
Okay.
Yeah, some guys tell us that they need bolts, which means if bolts came with the kit, they've been put somewhere.
Well, see, I ordered mine
Yeah.
separately, so when I got my mounts, the bolts came with them.
Yeah.
Yeah.
The only other piece you're going to need for this is a battery. We don't supply the batteries because sometimes these kits sit around for a couple of 3 years before they actually get operational. There's no reason to have a battery sit there. Now, just these batteries, it's a Odyssey battery, and the model number we use is PC625, and you can get those online for about $70. Or you can go to your local like Kawasaki four-wheeler dealer or a Bombardier Sea-Doo dealer and buy them for about $120 because they use them in those same things as well. But we've been ordering from a company called batteriesforeverything.com. That's the word batteries and then the number 4 and then the word everything. They seem to have them in stock virtually all the time, and their price is about as low as we've seen anywhere.
Is that the PC625?
Yeah, the brand is Odyssey. Again, the Odyssey battery it's an 18 ampere hour battery, but it dumps out its current in a big hurry. This has close to, well, it has 600 plus cold cranking amps. Whereas we've had guys who've used like PowerSonic batteries that you'll use in Rotax powered stuff, and they just don't dump the power out fast enough to turn that engine over.
Pete, what's the minimum RPM to produce a spark?
It's about 275 is the
Yeah.
absolute minimum RPM to produce a spark from the.
What's that battery again?
It's a PC625, PC625 from Odyssey.
Well, I also make that 680. Which
Yeah.
is probably more than you need, but.
Well,
is that
680
good?
is virtually the same. It's a slightly larger case, I believe, in one dimension.
It's wider but thinner. And
And-
actually, that's why I happen to buy that for mine at home. I didn't know at the time.
I don't think it makes any
Yeah.
difference which one you buy. They're so close in power output, I think it probably doesn't make any difference.
625 fits this little
Yep.
Yeah.
frame.
This box has been made for PC625. And we run 625s on all the Jabirus, all the Lightnings, and we have no issues out of them whatsoever. It turns the engine over wonderfully.
Closed cell, open cell, what kind of, or is that the?
This is called a fiberglass mat technology, and it's a gel cell. And it can be installed in any position except upside down. You can lay them flat, you can angle them, but not upside down. You know, one thing that you will find with the Odyssey battery, it works just great, especially if you use it often. But it gets to a certain point with that battery and it just quits, like overnight. You know, it'll get to be 3 years old and working just fine. All of a sudden, it won't start your engine anymore, and when it gives up in a hurry.
What they call the Deacon's one horse.
Now what we're going to do is we're just going to start fitting parts on here, and we're going to follow the outline that's in our 601 directions that you can download off the internet. The first thing to do is to pre-fit the engine mount.
I'm gonna get those nuts off.
One of the objectives in doing that. All right, let me show you why we're going to pre-fit this. There can be a little variation in where the mount bolts on the Zenith firewall are located. We've had a few builders where there was significant variation. And when these mounts come out of the jig, they can warp and shrink and change a little bit also. So if you have to stretch this mount or compress this mount to put it over the bolts that are coming through your firewall, watch what happens here. See, I can compress this. You see, I compress it, these go farther apart. I stretch this and they come in together. Then they don't fit the engine. So what we want you to do first is to pre-fit the mount onto the holes that you have, and it's basically the bottom ones that are the important ones. The top ones, yeah, there's some flex in these top ones, but these bottom ones are triangulated, and they affect how it fits on the engine. So what Mark's going to do is just hold it up there and see how close we are.
Yeah, we're off by about an
eighth of an inch, huh?
yeah. Come out just a little bit, Ed. Down. Yep. So we're off by just about an eighth.
Okay, this one looks like it's off by about an eighth of an inch.
We need to go wider.
Yeah. So what we're going to do, I'm going to go get a file.
Yeah, if you don't do it
I mean,
that way,
if you're off a 1/16th of an inch
that won't go on.
from center either side, that means you got an eighth of an inch, and by the time you spread that an eighth of an inch, it'll bring the engine mount pins a quarter of an inch together, and then it'll be hard to fit on. Yeah.
Yeah, you can move them that much.
Yeah, we've had a couple of guys who, I don't know how they did it, but they were pretty far off on the bottom holes, and we provided them with an engine mount that wasn't drilled, and then they could match their own holes to it. What we're going to do is we're going to fit the mount, then we're going to put the mount on the engine, again, after painting it and all that stuff. And then when you go to put the engine on there, you'll find you'll have one heck of a time fitting that on there, and you may wind up stretching those holes anyway.
So it's perfectly fine to file these holes, elongate them outwards, outboard a little bit. So that's what I'm gonna sit here and work on.
A lot of stuff
Mark's not going to do this by hand. He's going to.
private roads. You think that's gonna be too bad?
Oh, you should be okay. A light gray? Yeah. Do you think you're good at that? No. There we go.
They're getting close.
Okay, now that it fits on there.
Well, what's up with the top? We'll just push.
Yeah.
It's got paint in it, that's why.
Okay, that's good enough for now. We'll just do a quick little measurement here. And this is 250 millimeters between them, and we're at about 249. So that's close enough that everything will fit. See, that's a little.
When we come back off, we want to take the file and take the paint out. The hole.
Yeah, that'll work. One thing you might run into with the motor mount that's supplied is up here in this corner, this little bottom plate here on the motor mount's a little wide, and it's hitting this angle right through here. So what you can do is just take a hacksaw or something else to cut off this little corner right there, just so it fits nice and flush up against the firewall there.
On both sides.
And it's on both sides. On the bottom, it should not be an issue whatsoever.
Okay.
Well,
Now,
go ahead.
now that that stays on there, the other part of the temporary, we're pre-fitting the engine mount, and that's what we've done. And what we want to do here now, I think, is locate where the airbox is going to go and the battery box is going to go.
The orientation of the airbox is vertical like this. This is your inlet, your cold air inlet on the side, your carb heat inlet off the from the muffler in the front, and your outlet goes out to your carburetor. So the thing about this one is you need to orient it in here in such a way that you have to watch for a couple of things. One, you don't want it too high that the mechanism won't, that the flapper valve won't work. And the other thing you have to worry about is what you'd like to do is to get this as close to even with the carburetor inlet as possible. What have you got there, Pete? Because Pete's going to measure it there.
Okay, the carb inlet is about 2 inches below. It's about 2 inches below the lower engine mounts here. And what you want to do most of the time is get this box probably just about. Let me see here how I can measure that. Well, it's 1 inch below, not 2 inches.
Yeah.
1 inch below the mounts. So if we, yeah, that's probably about it right there.
Yeah. Now the other thing you have to look at is you're going to drill a hole through the firewall, and it's right about where this upper stiffener is, where it rivets onto the front of the firewall. So you have to take that into account too. You might be drilling through both of those because that's where the control cable is going to come through. The other thing you have to look at is this is a real tight fit right here for your fresh air coming off your NACA scoop into the side here. This will work right here.
Yeah. Maybe one of the things to do now that I'm looking at this is
You may have to take this one out.
anyway, stick a piece of your scat ducting on there and raise it up so that you still can get the scat duct under the engine mount and put it up so that'll work.
You cut the corner off of this.
When I did mine, I cut this little corner off right here, but I made sure I still had a flange that would butt up against the firewall. And looking back on it, you really don't have to do that because now after talking to Pete, you just put some, we use red RTV as a sealant all the way around, and that will seal any of the gap that you may have when you rivet this in.
Little gaps, no big deal.
Yeah, little gaps, no big, because put a nice bead of RTV around it after you've drilled your holes all the way through. Everything's, you know, clecoed in position. When you're ready to install it, a nice bead of RTV around it will seal up the rest of it there. So while we're here, Don, are you happy with this right here? What we'll do is...
What's on the back side of this, so that if you do cut that off, to get that flush feeling, like you just draw a line, just cut.
Yep, you can do that.
off.
You can
Yeah.
just trim that right off, but leave yourself a little bit of a flange there.
Okay. I like to do that is just you have a straight edge, something we can just
Okay,
like
well
that.
let's
That would fit it flush without.
Yeah, good.
go ahead and mark your
What limits how far inboard you can dare to come?
well, you want as smooth of transition between here and the carburetor as you can get. So if you get too close, you're going to have a 90-degree bend no matter what you do. But you're just trying to get it to be as soft a 90-degree as possible. All right.
Okay.
So I can pull that out of the way.
I should do some cutting on that corner down there.
Yes, that's the carburetor
Yeah,
heat
it's
air
just
filter
just
box.
a touch, but it'll be fine. The RTV will take the RTV will take care of that.
Corner.
Yeah, you don't want to have your carburetor pressurized. So this is just a dump valve. See, when the air filter's in there, this will be back off of this a little ways. So if there's too much pressure coming in, it'll just lift this flap up and bleed out into the inside of the cowl.
Okay.
But that's all that is.
Okay. Looks good to me.
Yeah, here you go. Permatex high temp RTV silicone gasket maker.
What you need.
That's it right there. 26B is the number on that.
Paint with metal to metal.
On the back side of the airbox, where the cable's going to come through the firewall, you need to sand out a little place on the fiberglass, enough room for the grommet that's going to be on the firewall and the cable to come through. So that's what we did on this part right here. One in each corner here. So one right up there. Yeah, when I did mine a couple years ago, I went rivet crazy, not knowing any better. Now I've done a dozen lightnings. I put one in each corner and that's it. And the Permatex seals the gap and it's no issue. Let's get another one up in there.
Hold the battery there. We can draw a little line right around the battery.
Yeah.
And
There's a, that's about where it, there we go. So you can take your battery, you know, the things I've got a wooden cutout of this, but you got to watch out also the depth of the battery not hitting the upper motor mount here, or this cross piece. And then the second part of it is where, actually that'll work right about there.
okay, is that about where you want it?
Yeah, I think that's going to work right there, Pete.
Okay.
It's not quite straight.
Yeah.
Now, you've got one rivet here that what I would do is I would drill that rivet out and either dimple it and put a flush rivet in so it doesn't rub on the back side, or the other possibility is that's where you drill the hole for your 3/16 rivet that'll hold this on. Do two 1/8 inch holes on the plate here along the center line that Pete drew. Okay, thank you. So go ahead and give me, I don't want to get it too close to this hole right here that we made for this rivet, but give me a hole somewhere right around there, and I don't know, something right around there. Just give me two 1/8 inch holes.
Okay.
And well, then we'll set it in place and we'll drill it through the firewall and cleco it.
Okay.
Oh.
Some people are way too.
Locate where the cabin heat mixer box is going to go.
Okay.
And now that we know where the battery is and everything, then we can get that mount out of the way.
Oh, okay, sure.
You have a clear firewall to work
You're
on. You don't
absolutely
have
right.
to drill around the mount members.
Yep, you're absolutely right. Where is his cabin heat kit? I can't see the forest for the trees.
Yeah, I think that's probably in cabin heat, and I don't know if you need to locate the fuel pass-through at this time, and
It would be good. And that's a matter
that
of
way you
personal-
can work on the firewall without that engine mount being in your way.
Right.
Yep. Don, decision time.
Exhaust pipe. They let-
Basically, the only place this really can go is somewhere right around in here.
Yeah, well, in fact,
This is what you're looking
Yeah,
at.
I've had
Somewhere
a
right in here.
couple of Sonics guys do
Now,
exactly that, and
the-
it just warms it up before it gets
issue
to
is
the bottom
this.
of
You're
your
gonna
airplane.
take
It doesn't burn anything.
hot air off of the car, off
No,
the
it doesn't
muffler,
burn a thing.
and it's going to run into this inlet. And 90% of the time, it's going to dump up, and then you have to dump it out overboard. Because the thing is this is off. You pull. Excuse me. This is pull on. It's blocked off the dump. It's going straight into the cabin now. So pull on, and it's up like that because that's how you're going to have to run your cable down. And that's why it has to dump up and overboard like that. You can't run it like this unless you run your cable from somewhere else and actually have it come up this way. So now it's pulled on like that. So, right about here is where you're looking.
And there's no conflict of anything behind the engine after it's mounted here?
No, because the farthest thing back on the engine is pretty much the carburetor.
The throttle cable comes through.
Your throttle cable will come through as close as absolutely possible to this center channel here.
Choke cable, what about
The
choke?
choke, same thing. The choke's right below it.
This throttle comes from the top, right?
Yeah.
Dual.
Oh, he's got the dual. That's correct. So, and the choke will come out right through the firewall also, as absolutely as close as possible to this center channel here, the gear leg channel. So that's what you're looking at, is right about there. Now, while we're thinking about this, is where are you going to put your fuel pump? Okay, that's one train of thought. Another one is, so they'll put it on the firewall. On the firewall's possibility of vapor lock. So, you know, it's half and half. All Lightnings, we put the fuel pump on the firewall, we don't have an issue with them. I don't have an issue at all. Me personally, I put mine on the inside because I didn't have nowhere else to put it on the firewall, on my Zenith. That's what I did. I mounted mine high on the inside.
I put mine in the wing roots.
Okay, there we have another one. So Don, if you're going to put it out here somewhere, that's what we need to know. Your gasculator's already in the plane. His gasculator's in the standard Zenith place in the center of the plane.
See, it's not, the gasket is not exactly etched in stone yet. That might
Yeah.
move.
So these are the decisions that you have to think about, but this is basically where this guy's got to go. And you have one other piece we have to put on, which is the oil recovery bottle. And usually it can fit right here, but you've got a dump that's coming up and then overboard. And that scat hose makes a pretty decent 180 turn coming down. The other thing you can do with the oil recovery bottle is I mounted mine here out on the engine mount itself. I just made a plate for it and some 8L clamps or cushion clamps and clamped it here. So there's a couple of different options.
Any problem with that, you think?
Mounting it there?
So you have 1 minute to decide. But this is basically what you're looking at. This is pretty much your best spot for it. Somewhere right around in this area right here.
So Mark, maybe tell him where you put yours. In.
This is where I put mine.
No,
This
no,
is
I mean not the box. Sorry, the fuel pump.
my fuel pump was inside and up right around here somewhere.
You got
So we're going to look at something like this. And what we can do in this instance is you have a straight fitting coming out here. He'll mount his pass through right about here. It'll come out, do a 90-degree turn on the rubber fuel line through. We'll have a 90-degree off of here, run straight up to the mechanical fuel pump to the carburetor. And that's basically how I run them on the Lightnings. Same thing.
If you put another 90-degree on,
Every time you change the oil,
this is not something you're doing every week.
Oh, no. You're doing it basically every oil change, right, Pete? Mm-hmm. And this bottle, it takes, it's like a PCV valve in a car, basically. It takes blow-by from the engine crankcase up into this tube, and it'll just drain in here. And Pete, you get what you say. Mostly it's just condensation.
A lot of it's water that's in there.
Yeah.
It's condensation from the air.
Keep the bottom of your airplane clean.
And yeah, it picks up oil as it goes through the crankcase, and it's a kind of a gloppy mess in there.
So,
Yeah, it helps condense the oil and the water before it goes out on the bottom of your airplane.
Right.
and it has a drain, overflow tube that comes off the side, and also a breather tube on the top, or breather hole on the top. But yeah, what you have to do is be able to slide this in you have to get it in a situation where you can slide it out. That's what you have to think about, so you can get it out of there.
Is it remarkable to put a drain on the bottom of the thing?
Some guys have done that.
Will it work?
Yeah.
So in a normal oil change, if you're burning a typical amount of oil, how much is in there?
That's how much was
That
Yeah,
much.
So inch and a half.
How much access when the engine is on? You know, you got the cowling off. How hard is it to get to that thing to get it?
In this particular, it's not too bad, really. It's more when you're trying to work in right in here is where you have a bigger problem. Should be fine. Grab the wheels there so it doesn't go forward. There we go. So.
These corners off with.
There you go. Yeah, I'll leave that one on there. That's exactly what I want. Yep.
About your air.
That's, we'll know whose is whose. If you find any resin on some of them, they're mine. That's what happened.
Okay, I got mine right there.
Mine are one down.
Yeah, mine too.
I just now noticed that.
I just did mine last week.
Yeah, I just now noticed that.
I'd scribe it from one side.
All right. He's gonna just hold it from rolling back on him. There we go. That's pretty.
How many brake lines you say you had?
Okay, next guy gets to do that on tape.
There you go.
If you need to make a right turn, just make it 270 to the left.
Which that's gonna be hot, Don.
UPS ran a survey.
You got a pair. Here we go, Don. What we'll do is we'll hold off drilling these holes out
Until we figure out the
until, yeah. Well, actually, would they be the same? Yeah, they can be the same. Because we'll use the outside holes.
With that gasket.
Yeah.
It's got a little gasket that comes with it also, but I just put Permatex on it when I do them.
Everything I put on my firewall is going to have metal to metal, and has to be that Permatex on it.
Yep.
Just as a general.
Next thing, oil recovery bottle. So, we got this guy in here. How are we going to work this so it comes out? Do you want to just shave a little 1/4 inch off of these? Go ahead and drill these two out to 3/16, because that should be a 10. That's good. Yep. And take these guys out to 3/16 there. You might want to mark it instead of drill it. All right. During the day, that's what the problem is. Does that look straight to you, Don? Stand back and take a look at that.
How about a backside deburr?
Yeah, I do. Yeah, in this instance, it really helps to have a long drill bit for this. So here's the battery strap. And that's about where it's going to go, right there. I usually put them all the way up to the top of the battery, right around the lip there. Don.
Is it how does it mount? Is this a removable strap?
Yes. And it's going to be nut plate on the back side. So I've got what? Well, there's a.
Okay.
There's a piece of foam that's a sticky side.
Your battery's not going to fit that.
Huh?
Because you're way over here.
This is going to be doing this way.
Is it going to fit like that?
Oh yeah, that moves enough. Oh yeah, we're good. I just want to make sure it was pretty much even down the sides there.
Get your piece of L-shaped line.
it on the drill bit and mark it. There we go.
Put it in the bucket.
What we're doing is now we're going to drill the hole that the cable is going to pass through the firewall. And what we need to do is drill it at the angle that we're from the bracket right here through the keeper and then into the firewall. That way you get the angle correctly and you're not trying to bend the cable when it's coming through the firewall. And we'll notch that out too. It might walk on you a little bit. If it does, just mark it.
Yeah, just mark the firewall.
And then we'll get
a little bit, and then you can go straight in from the.
Yeah, that's probably good.
Out of there. Go straight in from.
Can you see it from there, Pete?
Pretty much. If you
Okay.
go right between the. You have to do this all. And you just send it back or change it.
Let me get a grommet for you. Okay.
You'll be told and turn that.
What I'm going to do is I'm going to take this hole out. I've got a little 3/16 ID grommet here. And it's a 5/16 hole through the firewall. That's what will make it the grommet. It'll let the grommet set in there.
The grommet in the kit.
No, we're not.
0.18 cable.
The 0.18 cable.
Yeah, it's a rubberized bit. You ever see screwdrivers that have a rubberized? Okay, that's done by a dipping process.
This.
Yeah, so you use it whatever you want.
See this?
However you want. There you go.
It makes it like
That's done
that.
by a dip.
So you just.
Oh, this is going to be a very interesting weekend. Okay. What we need to do is we need to get some 1/8" rivets that should have come in the kit. I didn't have any red RTV, but this is what Jabiru supplies with their airplanes, so we're going to put this on here. So this will work just as well. Goodness gracious. Alrighty. Got a couple of Clecos in here. Okay, let's see if we can line this guy up without moving around too much. Yeah. Give me that back. Oops, what's going on there? Best we've ever done that one. There we go.
How about, gee, I didn't know it worked that way.
Yeah. All right.
Airbox.
Airbox is on, and that'll dry.
Yeah,
That'll.
that's really simple.
Okay. Starter solenoid and voltage regulator rectifier. The choice is yours, honestly. We try to keep the run between the battery and the starter solenoid as short as possible. Now, your starter cable is going to work over on this side, run around and attach, but then you can take it over. Some people drill a hole through here with a grommet, run it straight down to the battery, whatever you'd like to do. The other side of it, the other part of this is, same thing with this voltage regulator. You can mount anywhere here on the firewall. It depends on a couple of things, where you're going to run all your wires through. And for us, we usually run somewhere around the middle, and then start separating from there. You know, left bank, right bank for all your EGTs, CHTs, engine monitoring stuff. Horizontally, it's just however you want to work with it.
It's not going to have that plug on it.
It will have the plug on it. What we do is just carefully take a little pick, pop the plugs out, because it'll give you just that much more room to cut these. Actually, it doesn't give you a whole heck of a lot more room to cut them. But you cut this plug off.
Oh yeah, it won't have.
Yeah, I'm sorry, it comes with the plug. It won't have it when you use it. Just cut the plug off, basically. And then from there, you'll start running these wires. We can write this down later on with the two blues run over either side to the two leads that come off the alternator on the back side of the motor. The red and the yellow we pair together and run to the battery, and the black runs to ground, and the green is not used. So,
That's in the instructions, isn't it?
yes, I believe it is.
Yep.
So, keeping that in mind, you just run it somewhere close over here where you can take your yellow and red, run down to your battery, your black over to either to a ground bus bar on the firewall or directly to the battery, and then your two blues can run off this side also. Just take the two leads off the back of the alternator, run it to the other side, and run them around.
Two blue cells there, black to the ground bus. What's left, green and yellow?
Green's
Red-
not used.
Yeah,
Yep,
green's not used, the red and yellow.
Yeah, and we tie the red and yellow together, butt splice it to a number 10 gauge. That's how I work it.
And go to battery plus.
Actually, what I do is I run directly to the battery side of the starter solenoid.
Right.
That's just the easiest. It's a short run. It's only about so far. Because you got battery wire coming off of it.
Yeah.
So to your battery post to your starter solenoid.
Okay, you hand me the front.
I think before we decide on the final positioning of that, we'll put that
the
cross rod in there for the dual throttles and make sure we aren't getting in the way. That rod is going to be right up about that high, running across there behind the nose leg.
Yeah,
Is
I
that
forgot
problem
about that.
unique to the dual throttle? Making sure that we've got that cross rod in?
Yeah,
Okay.
Yeah, because
yeah. Single throttle is not used.
Okay. So we want to see that cross rod location before we make the decision on the real estate on these two pieces?
Yeah. Now you're going to have two cables, throttle cables, come through your firewall over here at the outside, somewhere right about there. So your starter solenoid has to be somewhere inboard of that and high enough that the cross rod isn't going to hit it.
Okay. So we need to mount those before we declare real estate
Yeah.
for these.
Yeah, you don't actually have to even mount it. Just put the nylon blocks in place and lay that rod there, and you'll see where the cables come through the firewall, and you can avoid that, and you'll see how high you have to be.
We'll see what we have left.
the blue wires, all of them are 16 gauge except for the yellow and the red, which we do it to a 10 gauge wire. We pair them up to a 10 gauge.
But your 16 to start goes right there, 16 gauges.
I believe it's
They all look
16
the same
gauge.
on the
Yeah.
side.
So.
Okay, what we're going to do is put the throttle arm extension onto the carburetor. You're going to take the carb right off to do that, Mark? Okay.
It makes it a little bit easier.
Now the reason we do this is the throttle arm that's on the carburetor, when that's connected directly to a cable, the throw is only about inch and a quarter. So when you're pulling your throttle in and out, you only have about that much movement, inch and a quarter, makes it pretty sensitive. So what one of our customers designed and actually manufactures for us is called a throttle arm extension. We remove the throttle arm that's on there and put Dave Jelani's throttle arm extension on, and then that gives us a cable throw of about 2 3/4 inches, which is just about normal for a push-pull throttle cable. This throttle arm extension comes in a little bag with all the hardware necessary and includes some pretty detailed instructions, again written by Dave Jelani, who has a kit box. We got some photos in there as well as text,
See if you can
and
work against me there. Okay.
easy to do when you have it right in front of you, but when the engine is on the mount and on the airplane, you have to be a little bit more of a contortionist to get in there to get this on and off.
There we go. Nope, still not. You can go ahead and turn it now.
Oh, wait.
Right there. And the second one, same thing. All right, when you take this apart, what's that one? When you take that out, note the orientation, because this is Mark's favorite stupid trick, is to put it back on top. And what that does, it'll work, but it throws off the cable and the choke, especially the choke. Now the choke wire is having to come down at an angle. And now I know better, but early on I would put these back on top and forget about, so make sure you put it back in the same place, which is on the bottom. On this little guy, this is real straightforward.
This is in my kit also.
Mm-hmm.
Carl, you're going to call me. I know you are.
Yes, I am.
A little bitty bag, you got it.
You used to have it, actually. I think they gave me yours.
Oh, that could be.
So the pieces, he has it all assembled for you. It's a machine piece that goes on the top there, and this piece, it's a machine cup. It fits right there. And then the trick is to get it done. Oh, there we go. Just like so. Put the washer back on, the castle nut. And then I need 3/8, 2 3/8. Yeah, it will.
What's the torque on it?
Oh gosh, now you're gonna ask.
He thinks you should.
You guys should
No.
know the torque for a
Yeah,
AN3 bolt, right?
That's about 20, 25.
No,
Yeah.
35 inch-pounds.
35.
35 inch-pounds.
20, 25, I believe.
Yeah. I didn't think it was as much as 20.
Yeah, okay.
Don't get a hemostat, get needle hookers.
there we go. And that's with the throttle arm extension on it. So that's part one. All right. Part two. There we go. Thank you. What we're doing is we're marking another hole that you're going to use to put the cable end stop through, because now this pivot point's, or not the pivot point, but the stop is up higher. So I'm going to go over the drill press, drill another hole through here, and also cut in a relief right here so your cable can go through, the wire part of the cable can go through. So I'll be back in just a moment there. It's all written out in the directions right there. All right.
We're just telling my wife it's off the use.
No, it'll work. Clean it up a little bit.
Seriously, tell me you don't think I walked into my office with one of those when I need a favor.
What we did here is we drilled a 1/4 inch hole according to the drawings, 3/4 of an inch down from the top, and then 5/16 of an inch in from the leading edge here, 1/4 inch hole, and then took over the bandsaw and cut a relief in there that the wire through the cable can pass through it when you put it in. So that's all we did there, cleaned it up, and now it's ready to go. You want to show them the
Yeah.
cable? Because what will end up happening is you have to take this cable end stop, well, we put it in the correct way.
Yeah.
Jam nut on one side, and then jam nut on the other side,
No, he said he was asking the wrong.
and then tighten it down as necessary. And you'll adjust this, obviously, as you see fit, but that's basically how it will end up there with the finished product.
You're actually, whether you're touching the brakes, every time you're doing the rudders, you've got movement.
That goes back on now.
We're gonna put this back on. Yeah. And the
Just do a quick point out here. There's an electrical terminal at the top here and a wire going from the engine intake plenum to that terminal. That grounds the carburetor. Make sure after you take the carb off and you put that back on that you reconnect that wire. Because there have been cases of, throttle cable makes a good RF antenna. And if it's not actually grounded to the engine or your panel or something, that it goes usually pretty close to the radio and can feed radio noise into your radio. So that when you put your car back on, just remember to hook that wire back up.
Is there a statement to that effect
here. Also, watch the orientation of it because it doesn't work well facing other directions. There's a lot of stuff going on back there. The distributor cap's very close to this also.
I don't even worry about that because I got the Becker radio. I won't be able to hear.
Yeah, I didn't have it inboard just enough, so it was knocking up right against the distributor cap here, and just wouldn't let the carburetor sit all the way in the boot. There we go, much better. So the other thing to watch for, and Pete will touch on this a little bit later on, is watch your your orientation of your carburetor here. Don't let it get cocked off to the side one way or another, because it will affect the EGTs on the from one bank to the other. And like I said, Pete will talk about that a little bit later on.
In our carb tuning sequence there, if one bank of cylinders is running hotter on the EGTs than the other, you can adjust that a little bit by tilting this carburetor. And what we mean by that is just loosen the clamp and then tilt the carburetor to one side or the other. And you would tilt the bottom of the carburetor toward the lean side, toward the hot side. It's pretty close.
You would actually point the bottom of the carburetor to the lean side.
So if you're...
Yeah, well, you can turn the carburetor, so when you turn it, the bottom of the carburetor, if your lean side is on the right, turn it toward the right. If the lean side is on the left, turn it toward...
Yeah, okay.
Tell them why that is, Pete.
We'll do our little carb talk a little later this morning. We'll confuse everybody then.
Yeah.
That's the next confusion.
Oh, exactly.
So it's just the carburetor is held with a hose clamp?
Hose clamp with the ridge on it.
My carburetors are held on with 2 rubber boots and some safety. There we go. Just in case. I didn't think it was all that important until I got a second-hand Quicksilver. And as he was leaving the grow with it,
There we go.
dry rotted core boot gave.
Set that mount right there on the floor for a minute. Now, why don't you guys
I do it
do
all the
this as
time.
I read off the directions. Okay, attach the female mount rubbers to both engine attach mount points at the top only. Top ones. Females to the top.
I think I got 2 for this.
Yeah.
Yeah, you got 2.
One for each side.
I'm sorry?
Mm-hmm.
There's not a washer that goes behind it.
Nope. Attach the males to the bottom.
Bisexual,
Something.
Okay. The directions next say stand the engine mount vertically on the prop flange, but this is good enough, and it's a little more stable that way if you want to do it. Okay, lower the mount down into the mounting holes on the engine backplate.
Okay, so we need the little hats out of there.
I promise you, I'll still respect you in the morning.
Are we going to do a copy of this video?
Edited.
Well, yeah. I don't know. We can do this a raw thing. We were here anyway. It doesn't matter.
Okay, the engine mount washers. That's this part right here, along with the other half of the mount cushion, plus an AN4-31A bolt
Which are
is what holds everything together. Did you find those
Right
bolts,
there.
Mark? Okay, let's open up the bolts. Oh, wait a minute. Wait
what's
a
wrong?
minute. Here's...
That one down.
Oh,
Okay.
Clear.
Just right at the top of the engine here, the clearance is very tight between the lead off the magneto and the mount cushion. So what we do is we bevel off the side of the mount cushion.
But only that one, huh?
I'm going to take that over to the bandsaw and just zip a little bit off. That's the only one that has an issue.
And
Just make a
where is
flat
it?
spot.
Conflicting right here?
Yeah, right
Right there?
Mhm. Yep. And this goes back to the original ignition coils that Jabiru had the lead over here, and it wasn't a problem. And then they were discontinued. Jabiru found a replacement, one of Honda's contractors, that had the same shape, but for some reason something was different inside there, and those coils failed too often. Now these hold up very well, but again, the lead is in a slightly different place, so we have to have a little extra clearance there.
Okay, go ahead.
We'll pop that on there, then that comes in there, then we have clearance. Okay, so then the next step is put it all together, put a male half on there, put this on the male half, stick a bolt in. Well, let's do one at a time here or they'll be falling apart. Or you want
Washer under the nut.
Yep.
Correct.
Which is big enough, Mark.
Over there.
All right.
Is that right?
Yep.
Yep, all the way through.
Okay. Now you see, since that bolt is recessed in there,
No, it's supposed to be that way.
we're going to have to compress these cushions with a C-clamp. So to hold the bolt in place, we stick a small socket in there just to, as a spacer, so that when we compress it, that the bolt doesn't move back up, keeps the bolt in place. So let's,
I don't have the C-clamp, but I've got,
we have a monster pair of.
Wow.
They're
Yeah.
not big enough. You need a bigger
yeah,
pair.
these are field expedient. And if you do happen to have one of these around the shop, or your neighbor has one, it makes your life a lot quicker.
Yeah. And what we have here is a metal locking nut, AN363, and a washer, and we just put that on there to get it started. Then we can tighten it up at any given time.
Okay.
Who wants to try the next one? Essentially what you're going to do is you're going to tighten the bolt up and you'll feel
Oh, we don't
this
have
come
that.
together.
Okay.
When that comes together, that's the right tension on the mount cushions. You see, that just slides right in there. And if your bolt is way out of a line, or you might hit right there, but get that, it comes in and you'll feel the bolt tighten right up.
Okay.
The length of the bolt is critical too.
Yep, AN431A.
The guy had put line too long.
So by hitting that metal, you don't actually start compressing that rubber at all. It just,
Well, it compresses it to a point.
And there's no washer on the head of the bolt.
No,
All right.
you don't put washers on that.
Oh, you already
bolt,
got
do you?
Oh, okay.
This one.
No, we do not.
This
Yeah.
one is kind of short though. Huh? Is that other one any longer?
It's just a touch longer. Just a different brand, it's the same.
Okay.
Back your bottom one up just a little bit so you can get to your, there you go, to the bolt and the,
You get enough space.
all right. You got the bottom two.
Now, I want you to know you've done the easy ones.
Yeah.
I can see that.
There's clearance up at the top.
I can see that's going to be fun to watch.
All right.
And, you know, at home when I did mine without any, you know, without the super channel locks or anything, you can do it with a regular pair of C-clamps. It will work. It just takes a little bit of time, a little bit of messing with it, but it will work.
No, that's a short one. That's the here it is. You probably still want it, but
Rolled wind underneath.
boy, this is going to be. Give it a top just go ahead.
And then bring your bottom of the plier out there so he has room to get the nut on.
No squeeze. Wait, you missed.
Yep, you're off.
Oh.
You're off on the top.
Okay, good.
okay, there we go.
No squeeze.
It goes right out.
It's like third molar. That's a reference we can all understand.
There's that third motor again.
Washer went too. Actually, I was kind of worried about those gorilla blades. Kind of dangerous.
Yeah, if they slip, they could, your career may be ruined.
At least drastically change. Got your washers
This
on
will
while
be
you're
the
working.
challenge. Because clearance is...
Threads?
Now one hint, this is the tough side because there's almost no clearance. One hint, if you're working alone, put the other 3 on, tighten them up, hang the thing on the engine, the weight, or on the airplane. The weight of the engine pushing down will help compress that. Might make it a little bit easier for you to get on there.
Easiest third molar I've ever done. Okay.
Okay.
Another issue is if you're working alone doing this, don't you have at least one friend left that you haven't let off?
That you haven't yelled at some point in time.
You gotta have one.
All right.
Okay, here's a. There's a 3/8 socket around here somewhere. Oh, duh. It's a 7/16. My fault.
Oh, that's right. It's
It's
a quarter-inch bolt, isn't
Yeah,
it?
there you go. Okay, you got that side. Let me get you.
Dog bone for that.
With a quarter-inch drive here. There it is. When you get done tightening them up there, it should have 1.5 to 2 threads
Yeah.
extending out
You
through.
feel it immediately when
Yep.
it hits that metal. When it goes to the metal, you feel it was just instant. Plunk. Anybody wants to do the next one just to get the feel?
You think you put that 20 foot-pounds on it?
I don't know if I put that 20 foot-pounds on it or not.
Well,
Well, this is
Bolt 125 inch-pounds.
Oh.
and you will snap the bolt. I've done it. I thought, oh, I'm good, and pop. Yep. Because
Two threads is.
Mm-hmm.
Okay.
yeah, it will.
When you hit the point, you feel it immediately.
No, you work on the nut. Sure, look, he's gonna give you the size. Okay. None of this.
Do you have the key next door?
Mm-hmm.
I need to go get Ben's prop flange tool.
How did he put it?
Okay.
This is
that's
like
the one.
printed on the regular card stock or
Yeah.
something like that?
That's
Yeah.
like,
The nut on this side.
Who wants
What
to
we'll need to do
wash
is
them
we're
out?
going to pick the engine up.
And we got nutters.
We're going to pick the engine up and align it and slide it over the bottom bolts, and then slide it over the top bolts and put a nut on the top. The bottom will stay on its own. But as soon as we can get the, and then if a couple of guys can just kind of
Yeah, chalk the wheels so the plane
chalk
doesn't
the
move
wheels and
backwards.
kind of guard it so that we aren't going to push the airplane back when we do this.
And just be careful around the side skins, because I've unfortunately bent one by accident down in Florida. So taking an engine on out, because you'll start muscling something around. So if somebody can, let's get one person like on this part of the motor mount, another person down here.
Actually, why don't we lift up and let me pull this box
that
out of
was
the
next
way
thing,
so
is get
we're
the
not
box
going to...
out of the way there. Okay.
Freeing up.
Yeah, we're good right there. There we go. So nice and easy. Which way you go?
Okay, up now.
Okay.
We're on the bottom.
Now, Carl, you can push. There you go. Carl's in. Pete's in.
Okay, it's not gonna come off here now. So.
All right. Here she comes down on the nose gear.
Now, Carl, they didn't have to be totally tight. Right?
No, not yet. They got the threads in there.
I thought this was-
I'm gonna stay right here just in case.
Yeah.
Let's see, where did that quarter-inch drive go? Right there. Okay, volunteer. Just start tightening them up, and the other. Somebody can put a nut on the bottom on that side.
Yep.
That's the classic searching the home himself.
Just thought you'd see if you can slip that one by. All right. You should. I don't remember. I have to look at my book. I don't remember what the values were. How many inch-pounds on an AN6? You're probably at foot-pounds by then.
It's 17 to 19 foot-pounds, I believe.
Yeah, because that's what the... yeah, exactly. That's...
You have a torque wrench over here, do you?
Actually, yes, I do. It's over in Nick's box. Down by the demo plane to the left, Pete.
I want to get everybody's email. I'll send out. I've got 3 books, and between the 3 of them, it tells you everything. A lot more important than that.
That's a 9/16, isn't it?
Yeah.
Even having the pictures, I can read.
Yeah, I need those.
I can read pictures. I have one of those too.
I got it set to 19.
I have one.
I grew up.
Oh, that's looking twice.
Oh, boy, this will be fun.
Just, I'm assuming that
This is kind of...
is in the center there. So if I come to about right there, no, you want to, what we're measuring here. What we're measuring here, you can do it with a string or a straight edge. We're going from the center of the prop shaft right at the end to the back of the engine right here. And that should be 28 millimeters off center. Well, we've got inches here, but it looks like about 1 1/8 inches, which is about as close to 28 millimeters as we're going to come.
Yep.
So that's, if you have that measurement, run your string from here to the center of the firewall, and right at the engine back plate, you should be, the center line of the engine should be 28 millimeters toward the left side of the airplane. That's a 3-degree offset.
The center line of the...
Yes, to the left side of the airplane. That cocks the engine to the right
And that tells us
to offset P factor and torque.
Okay, so it's on the video too.
Mm-hmm.
Gotta get the video feed. Because I'll never remember all this stuff.
Yeah, and I've had a lot of calls, probably 3 of them in the last week. I don't know whether somebody put something on the Zenith list or what, but they're saying their measurement was 50 millimeters to the right. Well, they were taking the measurement at the firewall. They were extending this line to the firewall.
Oh, that's off a bit, yeah.
And then when we had to measure at the right place, it was 28 millimeters. So the measurement at the firewall is approximately 50 millimeters.
Sure, probably what you're
Yeah,
progressing.
yeah.
It's an offset.
So the line is from the center of the firewall.
From the center of the
the measure
firewall
right here.
to the center of the crankshaft,
It's right here.
and then you're measuring at the engine back plate,
So,
which is this
you
half-inch
want
thick.
to put a
To get your
string from
airplane
there?
center line, you're coming from the firewall, and how are you orienting yourself?
All right.
Okay,
Pop flange.
next step. We're going to go a little bit out of order now from what my directions say, and maybe I'll redo the directions. But once that engine is on there, one of the things we have to do is replace the prop flange with the extension. So you got to hand those to somebody, and
All right, somebody start cutting safety wire off the 6 bolts that are up here and pull all that safety wire out.
Did that the other day, and I was wondering how you say.
we don't. We don't.
You don't?
If you look in your installation manual from the Jabiru engine, it says safety wiring down in the 2-inch extension is almost impossible. And they recommend some blue Loctite, and that's it.
I was cutting it with cutting. Nothing there.
I thought about standing that on end.
Mm-hmm.
The long side of that is almost exactly the same height as
Is
the
it?
bottom of the sump, within half an inch. You'd have to lift it half an inch. But I think I don't know what you measured it the other way. It's the happiest day of the shop.
Built things, so they were virtually unmaintainable. You couldn't do it. You got to leave sending a guy.
Okay. Now, to take this hub off, we need to hold the crankshaft. A couple of ways you can do that. We've got this little tool here because we do it all the time. Fits in and holds the crankshaft.
Good 2x4 with bolts will do it?
Yeah, a piece of wood with some holes drilled in that you can stick bolts in there to hold it still. You know, Jabiru says lock the teeth in the firewall. I just didn't like that idea. Anyway, we have here a breaker bar with a little helper.
Torque amplifier.
And then a 5/16 hex driver. So who's feeling strong this morning?
Let's see what it takes.
We'll start
Can't be harder than pushing the two.
with that one. Yep.
All right, here we go. Wasn't that bad. That was a big ass pipe.
You'd wipe your feet out.
Did you say blue Loctite?
Yeah, blue Loctite.
They had something on theirs,
Most of you guys know that.
on this original one.
Oh, that's what's going to go back on is blue Loctite.
Mm-hmm.
What do you have to do to clean these to put them back?
A little brush.
That's one. Who wants custody?
Okay.
Is the pattern important at all here?
No, not taking it off. The pattern taking it off is not important. The pattern putting it back on for the final torquing should be just like a propeller, diagonal.
Or if Don will let you have that one,
You got an extra one?
extra prop flange?
Yeah.
Yeah, I've got. Okay, the other thing to do is go in here and I'll get a little pick and we'll just clean out some of this excess Loctite that is in there.
Yeah. What do you do with that?
That or a. And oh, where's my? There we go. And you're ready. Just you can blow them out too and see if that. There.
Mm-hmm.
So,
There's only one way on this, or
yeah, it's drilled.
6 ways actually.
Yeah.
any
Yeah.
way to
One of
six?
6 ways.
Okay.
So a little bit of Loctite on the leading threads there,
Yeah, way but loose.
and then the long extension is back there.
Is there a right and a wrong side to the washer? By the way?
to them to get
Looks like
Yeah.
it's got a little concave.
Yeah, we got a wire brush on our grinder.
Yep.
Otherwise, just a little wire brush.
In a Dremel tool.
That looks
it has
like the
little
dirty
wire
side,
brushes.
so
Yeah.
that's probably how it was.
Put with a concave is
Facing the work.
Tool for everything.
Yeah,
yeah. So it's
yeah, concave toward the engine, convex side out toward the head of the bolt.
Exactly. Yes, exactly. Yep. I even have a couple of them.
What does that do?
That's enough.
that's Loctite. Yeah, that'll be
That's-
It's
fine.
more.
Helps maintain the
Pressure.
torque. Yeah, now what's probably easiest
Yeah,
is
with an
just
extension.
stick that on there.
Okay. Loctite.
What's the torque on this?
Next victim.
I like the way you keep it.
Everybody else gets hands out experience.
It does make a difference, huh, Pete?
Yeah, it does.
Go ahead and
The
start
direction of the
there.
cup on the Belleville washers
Okay.
there.
Cup is going to work.
The concave side needs to be toward the engine, the convex side toward the head of the bolt.
I'm sorry.
And it just
Take this one and go ahead.
helps a little bit to maintain torque. It's especially helpful on the propellers.
Yeah.
We've discovered, now that we've sold a number of Jabiru airplanes to the southwest, the Phoenix area and so forth, after a week in Phoenix you better retorque your prop, because it does dry out and shrink and it gets loose. And carbon prop is great. However, on our Jabiru airplanes it costs us about 3 to 4 knots in speed. Torque these up, it goes to 30, ultimately 30 foot-pounds. And what we like to do is set your wrench at about 24 foot-pounds first, torque them, and again we'll do that in a diagonal pattern. And once you get them all to 24, then set your wrench for 30 and continue on in the diagonal pattern, torque them all up to 30.
Okay. Pete?
Yep, 30 foot-pounds.
You want to do them twice?
I don't know about the specific name for those washers. We call them basically a cup washer,
They're
cupped washer.
Belleville washer.
Belleville washer. Yep. Because the props. All right.
Okay, what do we want to do next?
Safety
Well,
wiring?
nope. Nope, we don't safety wire 'em.
You can if you want to, but it takes pretty pretty
Well,
tricky fingers
Bob-
to get in.
I would, if we can get away with it, I wouldn't recommend it.
Yeah.
Yeah.
Now, in your installation manual, a Jabiru engine, it says right in there that safety wiring the bolts down in there is almost impossible. Now, some guys have done it with a notch screwdriver and they're poking down in there, but Jabiru, in their airplanes built in Australia, in their shop, Loctite, torque them to 30 pounds, that's all.
Loctite glue,
Yep.
30 pounds. Done.
So why don't we sort of go in priority, the things that are maybe give the most puzzling things to builders. We'll kind of do it in that order. We'll go cowls, then we'll go oil cooler. This is a lifetime air filter. I was looking for cleaning instructions here and I'm not seeing them.
Is there something on here? I can't tell what all there is.
Site, there are detailed instructions on how to clean these things. Now, a little story about these. We originally, the air filter that's in the standard Jabiru box, which is a little bigger than this and doesn't fit on the firewall there, is a paper filter. So we started out using paper filters, but we're a little bit smaller size, and we found that 9 out of 10 paper filters worked fine, but that 10th one, either the filter medium was a little more dense and it didn't pass as much air and the engines wouldn't run right with them. Others, we found that if you put the vanes in the paper filter running this way, they worked, but if you put them this way, they didn't work. So then we went to the K&N filter, which is a cotton material, not paper, and they claim 50% greater airflow, and we've not had any problems. And I think they do work. I put, my pickup truck has one of these fancy dashes that tells you the miles per gallon that you're getting. I put a K&N filter in there and my miles per gallon on the average went up about 1 mile a gallon.
So you get day and age. Yeah.
Mm-hmm. And now that's not very scientific because, but you know, I set that thing and leave it for 3 or 4 tanks full as I'm running around here and occasional other places, and you know, I was getting about 14.6, 14.7. Put that in, and the first 4 tanks averaged 15.6. So I thought it was about a gallon, and I don't think my driving was really any different, although it's not strictly scientific.
Yeah, that's pretty long.
I know it's a 601 Cal because it says it.
Yeah.
What is that vent for on the other side?
Yeah, the small one's cabin heat, the big one's is your fresh air into your airbox. All right. What we can do here, first thing off, is put the front half of your cowl together, and just the prop flange you just took off, go ahead and just eyeball it on here. It's not a critical measurement, but eyeball it to right about where it's centered in there.
And the split is not the center.
That's correct.
Yeah, the split is not the center.
Split is not the center.
So I'm looking from here to here and side to side. That's about right. Oops, until it moved.
T-Lor method?
Yeah.
I need that.
Oh, there we go. Yeah, that's. There we go. And what we're going to do is we're going to cut that out because that's got to fit over the prop flange here. So,
Preferred method of cutting.
Pete and I, we use just regular old tin snips, or real quickly, I can get the. You going to tin snip it?
Yeah.
Okay. Or if you've got a cutoff wheel, your Dremel cutoff wheel, whatever you want, both of them will work.
If that's flexible enough, you're not going to hurt it.
Yeah.
Yeah, I bought this particular pair of snips when I started to build an RV6 back in 1989. It's still my favorite pair of snips for some reason. Just they're getting a little dull.
Yeah.
Cutting fiberglass doesn't.
True. Fiberglass is about anything in. I've got a brand new implement kit for Harvard now, and I think it's unopened.
We can talk to you about that.
Okay.
Mark, there's 3 of them. A short distance to the rule, and I'll get the same kit.
Oh, really?
You've got another one of those spin-offs.
Yeah, just remind me next break. We'll go in the metal pile over there and start looking for another one. Yeah.
Okay.
Go ahead and get this guy out of the way. We don't need him for right now.
Do you need to sand this?
Eventually, yeah, you want to sand it.
It'll be done later because it's
Yeah.
Actually, you know what? Sorry, bring that back over here. I want to see something on it real quick. This is something I learned when I was doing mine. We end up putting a donut half on here. Well, you want to talk about the donut first?
Yeah. Okay. One of the things we tell you to do in the instructions is to make a donut out of 3/4 inch thick chipboard, plywood, whatever you've got. 3/4 of an inch. How do I explain that? The donut goes behind here, and this 3/4 of an inch spacing between the cowl, front of the cowl and the back of the prop flange, when you put the spinner on, gives you about 3/16 of an inch clearance. Gives you the proper clearance between the back edge of the spinner and the cowl. So that's why we're using these things.
So, put it back together again. This is when I was working on mine. Let me get a couple of spring clamps.
Yeah.
I'm just putting in a couple of spring clamps to try to help hold this thing together while we do it. All right, that'll help. Now we take the donut. Oh, and the other thing on this, on the prop flange side of the donut, go ahead and chamfer this bit in just a little bit. That way, where'd the prop flange go? That way it fits nice and flush up against the prop flange. If it, there we go. It'll help. Yeah, just chamfer the inside so
Yeah.
it bends along with this radius there.
See, if you have it the other way, on chamfered edge, then you've got this little
Yeah, that's right.
extra gap there that doesn't fit in nicely.
So, next thing we do, this is my bottom one, is I put the two halves together and I work real hard on a couple of things. One, we want this to run nice and even, at least I did. And the other thing is top to bottom and left to right. Is to see how this best fits on there. Because it's not perfectly round and you got more distance top to bottom. Now, Don, I want you to take a look at this because this is your plane. I want you to sit there and decide if that looks good to you.
What are you trying to get, equal distance?
Yeah, I'm trying to get it nice and even up and down, left to right, because this is basically how your prop, well, here we can do it this way.
On the spinner.
Yep. Don's going to get the chrome, or excuse me, this is a polished aluminum spinner. Same thing. You know, this is, it sits a little wide. These sit actually dead on.
That covers everything.
Spot
But,
on.
yeah, spot on. Okay. Yep. Yeah, you're hanging here off the sides just a little bit. That's just the way the cowling is. So we know that. What we're going to do is get this centered up very nicely the way you like it. And then we're going to trace along the bottom and the top around this.
Looks to me like it needs to go.
Yeah, I can only see one side of it.
Yep. Giving.
Now you're on the bottom.
Okay.
Because you've got a 1/2 inch clearance on the top.
You need to be looking like up here.
Yeah, I can see this side. You can see the other side. You're pretty much centered top to bottom there. And this is something to take your time on.
And if there's any error, cheat the error toward the top, because over time your engine is not going to go up. It will settle maybe a little bit. So if you initially set this right at the top, then after 50 hours on those rubber cushions, you may find it be right in the middle.
Yeah, I set lightnings always high, and they do sag over time.
What you're shooting for is aesthetics when it's parked with no thrust.
Yeah.
Under thrust, it may kick up again a little bit.
I mean, we all know people walk around the flight line going, you know, they're staring at your airplane. This is one of the things they see.
But you know, it does. If you have that prop flange too handy, that'll take care of that.
Yeah, it will. Okay.
Fiberglass spinner is 9" against 9", so
I think that's as
that
good
shows
as
a little more often.
Mark it and go.
Yeah, I don't know how good it is.
Hey, let me get, oh, we can use those little screws right there.
Can we take it apart?
Yeah, go ahead and take it apart. Yeah, I forgot I wanted to put those together. Yeah, we just need a couple of them.
Without all the influence of the
Got it.
Yeah, we're... Now you're going to put your block back on here using the lines you just traced, and also swing this around so it looks like it's nice and even across the top.
Okay, I can't tell that.
Okay, that's good here. Pete, if you want to...
Go this way.
Okay.
You come from the inside out.
Yeah, inside out, just drill straight through the
How does that top
cowl.
line look? Are you happy with the top?
It worked first time. Yeah.
Yep. All right. So now we've got that. Let's see, we're going to need a couple of spring clamps and some pop bushings. Yep. Spring clamps. And let's bring her over here. And the other thing we're going to have to do is comes in and behind, and you're going to have to turn the motor mount. Joggle, the bottom of the joggle is even with the top of the longeron there. Yeah, the bottom of the joggle is even with the top of the longeron.
So you kind of sit on the top of the skin.
Get a picture.
Hold on, let me.
See how that's lining with this edge.
So I need to go down.
No, this is for the camera. Just
Oh,
lining.
okay. I think that's perfect. Is it?
There we go.
Compare.
Yep, that's it.
Okay.
Now that's.
Another clip.
Yeah.
Sharp one. Got a long one?
I do, and let's see here. The other thing we need to worry about
Level.
is getting this level, and what we do for that is
Long level.
Measure up off the floor.
measure off the floor.
Oh.
Is
Yeah.
simple as
That might be part of it. That side is higher than the left
Yeah.
side. If we bring the left up, it'll bring that.
Oh, I hate this. What is this? Let's see, 42 5/8. 42 and a half.
You're not vertical.
Oh,
Oh, I'm on a vertical. There we go.
That's a little bit more. Bottom towards you a little bit more.
Toward me a little bit
There
more.
you go. There you go.
Yeah, it's
Pretty
changed
close,
by
isn't it?
16. It's off by an eighth. It's an eighth high on this side.
let's see what I did there.
This thing's... How are we looking vertical there? No?
You at the bottom.
Toward me?
A little more.
A little more?
Right there.
Okay. That's still an eighth. 42 and 5/8.
Didn't look like it did.
Okay, vertical?
Yep.
A little bit more?
Right there.
It's still a half.
Okay.
Kind of dirty there. We just need to come down a 16th is all it is. There, that plane.
You're measuring here or here?
I'm measuring to, I'm sorry, I'm measuring to the bottom of this flange right here. The bottom of the joggle. So,
Yeah.
there we go.
You-
We'll check those sides.
just for reference, you don't want to measure it to up here
That might be
because
different.
when they trim them coming out of the mold, this may be an eighth or a quarter different than that one. Who knows? You know, these guys take it out of the mold and go zip, and but the join line, of the cowl is right there, and that's where you need to be measuring to.
Right there.
Actually, we're right on. That's within a 30 seconds or so, and the eye can't see that, and there's...
Okay. Now, I think maybe
Yeah, here's a couple of things to watch out for, and I ran into this with mine, is if you start pulling back on this cowl, this is clamped up here, and it's not going to move backwards. So what you have to be careful for is you're bending it or you're pushing it, and what will happen is, if anything, don't push forward on it, but let it relax and sit naturally. Because if you pull back on it, as soon as you take this donut out, it's going to spring back, it's going to go wherever it wants to. So just kind of let it set naturally. I know it sounds kind of funny, but yeah, see, this one came forward just a touch,
and that one
and this, it seems to,
go back just a touch.
yeah. Okay, go ahead and clamp her right there.
So no pressures.
Yeah, don't force it back or force it forward, because when it does come undone, it will spring wherever it wants to go.
See, the bottom part of the cowl is fairly flexible right in here, and you can take the front of this cowl, instead of being flat across, you can actually make it angle back if you pull on it. Then when you go to fit the top cowl on it, it's not going to look very good. Or when you took the donut out of here, then the middle will come back to its normal place, and you'll have 3/4 of an inch clearance between the spinner and the cowl. So okay.
All right, now take a marker and trace along the aft edge of the cowl. Trace it onto the side of the skin there.
This is probably thinking ahead of where we are, but we're going to want to put the forward top skin back on.
Eventually, yes. When we do the top, we will. Yeah, we can pull this off now. It's no big deal to put it back on either, but. And there we go. All right. Set that over to the side there.
Oh, that did move around.
Okay, what we need to do is draw a line on the cowl, excuse me, on the side skins here, that's 1 inch forward of the rivet line.
That's true.
And then what we're going to do is take the measurement between the two, transfer it over to the cowls, and then that gives us our screw line there. So 1 inch in front of the rivet line. If you guys want to draw a line there.
Most flexible.
Yeah.
Because it was in my head.
Yeah, what you're looking at is you want the aft edge of the cowl 1/2 inch forward of that rivet line.
Okay.
Then the other 1/2 inch is for your rivet, for your your screws in the cowl. That's a 1/2 inch forward of the trailing edge of the cowl. Does that make sense? You have your rivet line, the trailing edge of the cowl is a 1/2 inch forward of that. Then the screws in the cowl are a 1/2 inch forward of that. It gives you a little bit of edge distance there.
Now, do you want to?
Okay, now what we're going to do is demonstrate an alternative way to measure this. And let me have that ruler and the Sharpie. Before you, and to do this, before you even put the cowl on, we're going to establish a reference line relative to the rivet line that puts the firewall on. So what I'm going to do is measure 1 inch aft from the rivet. And again, you can do this vertically or horizontally. It doesn't matter as long as you do it the same on either side. Well, this is pretty easy. You've got your rivets spaced. Well, that one's not quite. Okay.
Pete, let's do that on both sides because that will work better.
Okay.
Yeah, let's do that. Hey, Carl, give me a line 1 inch aft because it will work better that way.
Okay. So we've established this reference line 1 inch aft
Run it parallel.
of the center line of the firewall, or the rivet line that rivets the firewall onto the fuselage. We'll put the cowl on, and then we'll measure 1.5 inches forward of the reference line, which will give the back edge of the cowl, the trim line, 1/2 inch ahead of that rivet line. And then we'll measure another 1/2 inch for another line. That will be our line for the fasteners that fasten the lower cowl to the skin.
There we go.
So we need to go through the clamp and level.
It should
Again,
line up
that should have
because
stayed.
the engine should not have turned. And just clamp the little guy right there, Carl.
Yeah, I guess I am on there.
It is. It is lined up barely, but it is.
Okay.
Okay.
Let's draw 2 lines on here right now. Take and draw a line that's 1.5 inches forward of that line.
Got a marker?
Right here.
Let's
Okay.
1.5 inches and another one at 2 inches. So while you got your mark there, just make 2 marks on the same.
Okay. I noticed when you drew this.
Here, I've got some roll arounds. If somebody wants one, we got a roll around here.
I'll take that.
There you go, Carl.
Just
There's 4.
figure-
It's just difficult for me to
okay.
read.
Then we just do a connect the dots.
Yep, connect the dots.
Well, okay.
Yeah, that's safe.
It's the best place. And then actually, Pete, in this application, because
curious about how much variation there is between.
Well, the apps, yeah.
All right.
Well, just remember,
It's not a critical dimension.
yeah, it's not, and it's however he trimmed it when it came out of the mold.
Yeah.
So,
Okay, let me get in here. And
As long as it didn't trim it too short.
let's locate our fasteners here. Now, your bottom fastener is going to be right about there. Okay, not critical. Pick a point. So it's going to be right about there. And I'm going to just take and measure from there to the joggle. And I have 18.5 inches. Well, if I pull this down, I have 19 inches to the joggle. Okay, the first one is going to go an inch below the joggle, so I have 18 inches to work with. Divide that by 3, that means every 6 inches we have a fastener. So you guys with the markers and the ruler measure down 1 inch and then 6 inches, 6 inches, and 6 inches. Make a mark, and we're going to drill some holes, put some clecos in. Let's rethink this. If we want to be an inch up from the skin, then it's 17 inches. So either got to make our last interval 5 inches or respace the whole thing.
Make it 5 inches, be 16
Well,
inches. That's
Make it 5? Okay, make it 5 on the last interval.
Okay, so what are we doing here?
yeah, just, you're doing 6, 6, and then 5.
That should put it
Yeah.
1 inch above the bottom of where the skin goes.
Yeah, so 6, 6.
Yeah, I guess I was thinking that skin went a little farther down
Farther,
there.
yeah.
But, okay. There's a drill. Clecos are right there. Cleco pliers. We can
Yeah, I've got,
start.
there's 1/8 inch drill and copper clecos. Okay, is everything?
Yeah.
Is there any?
Yeah.
Before we drill.
Last chance before
Yeah,
we
Ed,
drill.
hold on just a second.
Are we really balanced on both sides in terms of?
Yeah, I just want to make sure that
Let's
that
take
there's no.
one more look here. This looks to be 42 and 5/8. This looks to be 42 and what the hell is 5/8 on this thing?
That's what.
42, yeah, it's about 42 and 9/16. I don't know that I could get it any closer than that.
I don't think you can measure it that
Yeah, that's
close.
what.
I think the
Oh, that's all skin,
Should be cleco pliers down there somewhere.
In my pocket, 'cause I was.
one Cleco.
Matter whether you do one on each side and work down, or
I would work, at least work down.
Work down.
But one on each side, it probably doesn't matter.
we are the inside.
We can still do it.
This will be fine.
Yeah, as you're working your way down, make sure you're pulling the cowl nice and tight against the side of the fuselage there. Don, they got you.
I thought it was a cow flat.
Go ahead.
Hold on, while it's still flat, go ahead and draw the reference line. Well, I hope it's a 1 inch. It should be.
Well, these are cam locks, so they need a little bit more room maybe than the nut plates. So if we draw our reference line back an inch again, and then forward of that, we'll draw the trim line 1.5 inches forward, and then let's go another inch forward from that for our cam lock line, because those cam lock receptacles take just a little bit more room.
We'll start an inch back. Instead of 1.5 inches and 2, we'll go
1.5 inches and 2.5.
1.5 inches.
Do you know if the top's, is it trimmed longer than the bottom? Let's check
I
that
don't
real
know.
quick.
Let's just
slide that out of the way
set
for
this
just a
here
second.
just to make sure that
Make sure an inch will do it.
we aren't trimmed so long here.
Problems.
Whoops.
Oh, it's going to be fine, Pete.
No, that won't be too much trimming.
Oh,
Look at
no,
that.
not at all.
Look how nice that fits there. You're not going to have trim that hardly at all, are you? In fact,
The reference line will be 1 inch back.
Half inch, I believe you said. Half inch back from the rivet line.
No, go
well,
an inch back
let's
from
go
the rivet
1
line.
inch back
Yeah.
from the rivet line, because there may be some cowls that come out of the mold and they trim them a little bit longer, And you need the reference line to be exposed so you can measure off it once the cowl's on there.
Drawing this line with a lot of references in segments because it's a curve.
So we would prefer 630.
Okay, we would prefer 630 if we can. Yep, okay. Go about 2 inches, because that way nothing up here moves. I guess it won't move anyway. I know when I build lightnings, I build them with 2 inches off the front.
Now, in preparation to put the top cowl on, what we want to do is make sure when we're measuring this that that top cowl doesn't move relative to the bottom cowl. So what I did here was located the spot where we're going to put the first cleco, eventually becoming the most forward cam lock that holds the cowl together. And what I did is I measured 2 inches back from the front and a 1/2 inch up, and that's where that first cleco is going to go. Then after we trim the top cowl, the length of it, then we'll space out 5 clecos along the side here, evenly on each side, and do the halves together. There might have to be a little trimming in that the top cowl might overlap the bottom a little bit, and if our fiberglass guy has trimmed them the way he should, it should overlap that, because we can always trim off, but if we're short we can't add on. So the first thing we'll do then, 2 inches, and if it's 2 1/2 or even 3, I don't think it makes too much difference. So now what we're going to do is somebody get the 1/8 inch drill.
Where's the drill? There it is.
Again, we'll hold this
And what is this, a half?
1/2 inch up. So go ahead and drill that right there. We'll hold that nicely in line so that the front matches up good, and just drill right through there, put a silver cleco in it.
Okay. This is your spot.
Yep.
All right.
Now let me,
What are the specs on this again?
what we're doing is locating the first cleco, and we're measuring 2 inches back from the front of the cowl and a 1/2 inch up. And the reason we go a 1/2 inch up is we have a 1 inch lip here on the joggle, so to make the eventually the cam lock body dead center in the joggle, it's a 1/2 inch up. So we'll hold that nice together right there.
There you go.
And a silver cleco. Okay, now that's going to keep the front of your cowl top to the bottom in place while we operate on the back here. So now we've drawn our reference line on the skin. We want to trim this thing a 1/2 inch ahead of the rivet line for the firewall. So we want to go 1.5 inches forward to this line. And there's a marker there and a ruler there. Forward of the line that we've drawn. What we're seeing is the edge of that skin is 1 5/8 inches ahead of our line. So done, we can either trim the whole thing up across the top here at 1 5/8 inches, and we get to about this point here, then we come down and match it to our trim line down here, or we can hold on our 1.5 inch line, and I think we would be better to do 1 5/8 inches, because everybody's going to look at this and they're going to reference it off your line of rivets. If we keep an even spacing off the line of rivets, and then from about this point here, we'll just do whatever it takes to line up with our trim line on the bottom cowl.
That's my
John, you getting that?
Remark this at 1 5/8 inches, which on my ruler is right about there. 1 5/8. That's probably about as close as we're going to get it.
Government work.
So, what we're going to do is measure this, and that is, well, we'll start with 1/8 of an inch.
So you trim it, you're going to trim off an eighth.
Mm-hmm.
Yep. Measure 1/8 of an inch right there, and we're going to go with a line from here to about there, and this is just a sanding block job essentially.
We're trying to get it to fit into that channel. Is that
Yes,
the game?
yep.
Okay.
We're overlapping the joggle a little in the back,
Okay.
and that was done intentionally.
I'm going from nothing.
Yep.
I don't think it does that, but
Just to take a look, Mark, let's. Okay, we'll bring it over here to the table. Now,
what would you like?
where did my tin snips go?
Put them away.
Okay.
I gotta put away.
To cut this
I'll
off
lock
with
I locked them.
the tin snips, but I'm going to leave the line and a little bit extra on it there.
Because this is an aesthetic edge you want to see.
You see that well enough, John? I can turn this way a little bit more here.
There's a cut-off wheel on the drive.
Or if you have a cutting wheel on a die grinder, that works too, but this makes a lot less dust. Okay, then this is a tool that fiberglass airplane builders will have. It's called a permagrit. This is a 12-inch long permagrit sanding block. Permagrit does great stuff on fiberglass, but you can do it with sandpaper and a sanding block.
Yep.
And we'll just make the as far as I'm going to take that for now.
Yeah, the bottom all set.
We'll trial fit it 3 or 4 or 10 times before we get it just the way Don wants it.
Do the other side now?
Yep, we'll do the other side now. We have a volunteer with a strong, do that line also. You know, leave a 1/16 from the line.
Kind of just left of it.
Joggle joint where it needs to be stiff to hold it. The cleat goes in the front part there, and see what we see. Maybe a 30-second off yet or something in the final cleanup. Hey, Don,
Yes.
I think we're going to call this good enough now. In your final cleanup before paint, if you took another 30-second off.
And it created a little bit of a
yeah.
beveled edge inside,
Yeah,
so it
you make a
comes in
nice
better.
straight edge. Just essentially clean it up a little bit, and you'll be just right.
Okay.
Take it.
Got it.
All right.
Okay, what we're going to do is measure the distance between the aft hole that we drilled and the front one, and we find it's 34 inches in this case. We're going to have 5 clecos, so if we put one right in the middle at 17 inches, there's our mark. One halfway between that at 7
8
and
and a half.
8.5, there it is. I was looking at that. At 8.5 inches and one at 25.5 inches, that spaces our 5 clecos out along the side here. And then when we put the cowl on, we will measure a 1/2 inch up from the joggle, and that will be the center of the hole that will eventually become a cleco fastener. For now, we'll do it with the silver, not a cleco, a cam lock fastener. But for now, we'll drill the 3/32 holes and do silver clecos to hold the whole thing together. And that will complete the cowl installation, except for the hardware, installing the cam lock bodies and the nut plates and so forth. And we'll get to that after lunch.
Dana should be on her way in a few minutes.
I'm sure my firewall full.
I just I don't want to drop it.
I don't want you to drop it either. There we go. Yep.
Not bad.
Yeah, it's going
Just a touch high, and that engine will settle in nicely, and it'll be just about perfect, I think.
when it's on my airplane, then it will.
All done taking photos. There. The Bing carburetor is a fairly complex piece of machinery that accomplishes a pretty simple task. In concept, as you go up in altitude and air thins out, you need to reduce the flow of fuel that goes into your engine to keep the mixture right. And the Bing accomplishes that by moving a needle, a tapered needle, up and down out of a jet. When it lowers the needle down, the needle is thicker, reduces the flow of fuel. When it pulls the needle up, it gets to the thinner parts and allows more fuel to flow. There's a couple of other things that interact here. The pressure that's in the fuel bowl's in the bottom of the carburetor, and I got the bowl off of this already. The more pressure in the fuel bowl, the faster fuel will flow through the jets. So that affects things. And then the amount of air that's going through there affects things as well. So what we're going to do is dissect this carburetor a little bit, take it all apart, and then try and give an example of how this all comes together. And the reason we do that is the altitude adjustment, or the mixture control portion of this carburetor, is controlled basically by the load that's on the prop. And the load on the prop comes from a number of different things. Number one, the prop design, diameter in inches of pitch. And number two comes from the airframe. It's a lot more work to drag a Zenith 701 through the air than it is a Lightning, for instance. So at a given RPM, you'll have more prop loading on a 701 than you will on a Lightning. So I guess the place that we're going to start is to just take this thing all apart. The jets themselves, we'll start at the bottom and go up. The jets themselves are in the bottom, and we refer to this as a column of jets, because in the bottom is a main jet right here, and then the fuel flows on up through into a needle jet that's up inside. The needle jet is the one that the needle goes up and down in. Essentially is a variable jet. So to take these off, it normally requires an 8mm wrench in the bottom here, but we had this apart so many times I don't need the wrench to take that off. This is a main jet, and if you like, just go ahead and pass that around and take a look at it. In the column of jets above the main jet is what they call the spacer. Just a machined brass piece that puts a little distance between the main jet and the needle jet. And that's all that is, just a threaded machined piece of brass. Okay, sitting on top of the spacer is the needle jet. It sits up there with the big part down, the small part up and protruding through into the throat of the carburetor. This is a needle jet. Then there's one more part. This is called an aerator, and the needle jet sits inside of this and is actually, the diameter of the needle jet is smaller than this. You can see there's holes along the side of this, and as fuel flows up through, it's mixed with air that comes in through the side, atomizing and aerating the fuel mixture and making it actually combustible. So that completes the column of jets. The jets draw fuel from a float bowl, and maybe that goes the other way. I'll take the floats off of here. Floats are held in just with a little pin, friction fit pin, that for some reason doesn't seem to want to come out here this time. There it comes. Pull the pin out, and there's the floats themselves. Pretty self-explanatory. The floats push up on this little valve body.
And these are solid, as opposed to hollow?
Yeah, those are solid. This little valve body, you see a little neoprene tip on it, goes up into the carburetor. There's a little brass seat in there that when the floats go up, it pushes the float valve up and closes off the hole, shuts off the flow of fuel. Okay, hang on.
There's a little
Hey,
internal spring.
the valve body that I'm passing around has a pink tip on it. And that has a weaker spring. Bing has another model with a stronger spring. For years, the pink tip was fine until Jabiru went to the bigger carburetor, which the spring on the pink tip wouldn't quite close it under more than 2 or 3 pounds of fuel pressure. So now the float valve body that you'll see in there has a black tip on it and a stronger spring.
Get up to about how many pounds?
Oh, they say 4, but some guys are doing more than that. Okay, here's your, go back to the column of jets again. Here's the spacer. And in the bottom of the spacer goes the main jet. Okay, with a little washer on it. And then above the spacer goes the needle jet, something like that. I don't know if you can see that well enough, John. And then the aerator sits on top of the needle jet, something like that.
The holes are at the top or the bottom?
The holes actually protrude, the holes are at the top and they protrude through into the body of the carburetor. And if you ever take it apart, you'll see if you try to put it in upside down, the hole in the body of the carburetor is a lot bigger than the lower half of this aerator, and it really only fits one way. Okay, in the bottom of the carburetor, there's 2 additional things we're going to take out here. There's what we call the idle jet. The idle jet is the most complicated one. in that it has a series of little holes along the side and that funnels fuel in and out the top there. The engine actually operates on the idle jet from 800 RPM idle up to about 1100 to 1200 RPM is where it starts to add input from the needle jet as well as the idle jet. But if your engine is not running right at idle RPM, then that has something to do with the idle jet or the idle mixture. You can pass that around if you like. The idle mixture is adjustable. And the bottom of the carburetor here, this is the engine side that I have my finger on. Inside this cast recess is a little valve or jet. It's a needle, actually, I should say. Just a little thing with a needle on the tip of it, and that controls the amount of fuel that goes into the idle air, the idle circuit. Now, those of you who have flown ultralights with two-stroke Rotax engines with Bing carburetors will be shaking your head and saying that's not right. But the two-stroke carburetors limit the air. The Bing 64 and 94 carburetors, the mixture, what you're adjusting is the fuel, not the air. So when you adjust your idle mixture, when you screw this jet in, it limits or shuts off the flow of fuel. When you screw it out, it richens it up. In the normal position, if for some reason you're idling and blowing back black smoke and so forth, screw that screw in till it bottoms out gently, then screw it back out 1 to 1 1/4 turns. And that is the typical correct position. Now, you guys in Wisconsin or Montana in the winter may need to back this out a little bit more to provide a richer idle mixture, because those cold intake pipes will make it a little tougher. It'll be a cold engine longer, and you'll have to run with the choke on for a longer time unless you back that out. When we were in Wisconsin in the winter, we backed it out a half a turn over what it was in the summer. Okay, now inside the carburetor we have a slide, some people call it a piston, and that's connected to a diaphragm in the top of the carburetor. I'm going to open this up and we'll take a look at this diaphragm, because that's the heart of the mixture control system. Okay, take the top of the carburetor off, and that's just a casting. Inside there is a spring which helps push down on this piston. And then the piston diaphragm assembly is all one piece. You can see the rubber diaphragm there, and that allows this piston to go up and down inside the body of the carburetor. And there you see the tapered needle. Now, this is an old one that's not our current needle shape, but for illustration it works just fine. The carburetor, airflow through the carburetor is controlled by the butterfly, which is right at the engine side of the carburetor. And then there's a few passages in here. The throat of the carburetor, you see these two openings at the top. Those openings feed air to the bottom side of that diaphragm. See, they just come out right here. So the bottom side of the diaphragm is seeing a pressure, whatever comes through those holes. So that's the pressure of the air coming in through your airbox. The back side of the piston, and as you're looking at it there, when it gets back up here, I'll point it out. Air to the top side of the piston comes through these two little holes in the bottom of the piston. Okay, so this is vacuum. Piston sits in this carburetor like this. The diaphragm sees the incoming pressure of the incoming air through here. That's the bottom side of the diaphragm. The top side of the diaphragm sees the pressure on the engine side of the carburetor, or pressure coming from, let's call it, engine vacuum. It may not be the exact right term, but it illustrates our purpose, I think, well. The amount of engine vacuum that the top of this diaphragm sees, obviously that determines how hard it'll pull this up. Okay? And the amount of vacuum that this diaphragm sees, the top side, comes from the engine side of the carburetor through the bottom of that piston. Well, between that pickup point for engine vacuum, let's call it, and the engine is a butterfly. So the position of the butterfly varies the amount of engine vacuum that the top of that diaphragm is going to see. Let's take an illustration here. Picture this. If you're flying along straight and level, let's say it's at 2,800 RPMs with your Zenith Zodiac, your mixture is balanced and everything is right. You pull the nose up 30 degrees. You don't do anything else. What happens? Engine RPM decreases because there's more load on the propeller. Okay. If you do the opposite, put your nose down, the engine will speed up because of less load on the propeller. So that's the concept that we need to address when we're talking about tuning the carburetor to the propeller and the airframe that you're going to use. Now, if you use a Jabiru propeller in a Jabiru airplane with a Jabiru engine, your carb will be tuned correctly to start with. But if you're using a Sensenich propeller, which has a little bit more bite to it than a Jabiru propeller, in a Zenith Zodiac airframe, which is a little bit more draggy than a Jabiru airplane, your carb tuning will be a little bit different. And let's look at it in this way. If you picture yourself flying straight and level in your Zenith again, and you bring the nose up a little bit, well, RPMs drop it, but you want to keep the same RPM, so what do? Push the throttle in some, right? You open the butterfly more and expose the top of the diaphragm to more of the engine vacuum. Well, here's where you take two planes side by side, a Jabiru and a Zenith, and they're both at, or let's make it more drastic, let's say a Lightning and a Zenith. Lightning at 2,800 RPM and a Zenith at 2,800 RPM. Which one is going to have that butterfly farther open to maintain 2,800 RPM in level flight? It'll be the Zenith or the airplane with more drag. So what we find, because the butterfly is further open, there's more vacuum that comes to the top side of that diaphragm, pulls that needle up and richens up the mixture. So to compensate for that, what we have to do is change the jets so that we get the right mixture for the prop and airframe combination that we're working with. Generally, the more load that's on the prop, or the prop transmits to the engine, the smaller the jet will have to be because the needle is pulled up farther out of the jet. The standard jet coming with a Jabiru, the needle jet is a 285, I believe, 2.85. And For a Zenith Zodiac, we may have to go to a 2.80 or even a 2.78 if you're using the Sensenich 64ZK49. Now take the case of a Lightning. It's a little tougher on that airplane because we're using a 62 by 58 propeller, and we can still overspeed that thing, but when we push the throttle in for takeoff, we're only getting 2,500 RPM. Because of all the pitch that's in that propeller, it limits the load there. But at a 2,800 RPM cruise, our butterfly is farther closed than it will be on a Jabiru airplane or on a Zodiac. Being farther closed, the top of the diaphragm doesn't see quite as much vacuum, the diaphragm relaxes, leans out the mixture. So we have to go the other way to a larger jet to balance things out. That's the basic theory, the basic mechanism behind what we're doing, what Bing is doing with these carburetors. Now there's a couple other factors that enter into the mix here. One is the pressure in the fuel bowl, because the more pressure in the fuel bowl, the faster it will push fuel through those jets. Pressure in the fuel bowl is determined by the bowl vent, which on the front of your carburetor is this little nipple here up at the top. As you look at it, it would be at the 1 o'clock position as you're looking down the throat of the carburetor. This goes directly to the carburetor bowl. And what you have to do with this is run a plastic line from here to the same place your incoming air is coming from. In other words, the clean side of the air filter. Okay, that keeps the pressure in the bowl the same as the pressure of the incoming air and keeps things balanced inside the carburetor. Tell a little story here. Back in 1999, when I first became a part-time Jabiru dealer, I was right up the road from Sonic's aircraft, and they'd put a Jabiru in their Sonics, and we're having a heck of a time getting it to run right. It was just perfect climbing out, strong, powerful. They would level out, speed would pick up to 150 miles an hour, and it would begin to miss and belch black smoke, and was obviously running over rich. Well, I didn't know it at the time, but looking back on it, what their problem was, and they tried every different kind of jet imaginable. What their problem was, nobody told them that they had to hook up the carb vent to the clean side of the air filter. So when they were climbing up, speed wasn't too great, angle of attack was high, pressure inside the cowl was probably the same as the outside air. Then they leveled out, picked up speed, 150 miles an hour. Pressure inside the cowl built up. The vent that they had was just open to the inside of the cowl. Therefore, pressure in the carb bowl built up, pushed fuel through the jets faster, richened the thing up, and it wouldn't run right. So that's an example of what happens when you don't have the pressure in the bowl equalized with the pressure of the incoming air, so to speak, because that all works in concert there. So have I lost anybody?